Hello everyone. So today we are going to do another LeetCode problem, and today the problem statement is reverse string. So it's a very classic LeetCode problem, and it is base problem for a lot of uh, medium and hard level problems that is asked in a lot of interviews. So we are going to implement our three-step method here to solve it. Let's do that, and our first step is to read the whole question with example. Write a function that reverses string. The input string is given as an array of character s. You must do this by modifying the input array in place with big O of 1 extra memory. So we are not allowed to use any extra memory, uh, any extra dynamic memory. So we can have 2 3 variables that should be constant, but we can't make it dependent on the array length of the string. So that means we can't have another array in this, and they have already stated that we need to do it in place. So example 1 says that hello, and if we reverse it we get O double L E H. Similarly we reverse it and this is the output for that. Now for the step 2, think of 3 4 test cases other than the one provided in the question. So I have written 3 cases. First one is AAA. If we reverse it, it remains same, AAA. For world, if we reverse it we get DLROW, and for LeetCode we get DOOCTEEL. So this would be reverse of LeetCode, right? Okay, so now in the step 3 we need to write down your thought process while you find a solution to this case. So for how I see it, so I started from the last and went my way to the starting, so that I get the last word, that is D, then L, then R, then O, then W, right? So first thing is we need to do iteration. Let's write that iteration is required. You can start from start as well. Then we need to add the values from the back, like you will be getting the W that comes to the last position, then O comes to the second last, like this. So iteration is required. Whatever the way you want to do it, from front end, from forward or backward, it's up to you. So iteration is required. Second thing, since we need to do in place changes, so swap is required. Whenever you see in place, or whenever you see that you are not allowed to create any other uh, array or memory uh, complexity is given, that means you have to use in place, or you have to do some kind of swap is required. Swap, right? Swap is that I move this value here and I swap it from the last value. So we need know that swap is required from this two things, from the problem statement itself. So in place means we need to do any kind of swapping, because it is in place. We can't have any other array where we can add values and then we change the value to this. So in place means that any kind of swap is required, and iteration is also required. So if we try to do swap of this, so W would be swapped with what number? Should I swap it with O? That doesn't make sense. It will give you OW. If I try to swap it with R, it will give you ROW. That is also not reverse. If I do with L, then also it's not work. It will not work. But if I do it with D, that is the last index, uh, we will be able to get two things sorted out. Let me show you. If I swap W with D, I am moving W to its correct position, and I am moving D to its correct position. So with one swap I was able to correct the position for both the letters that is in front as well as in the back, right? Okay, that means I need to do swapping of first and last letter. That is one thing that now I know, right? Swap first and last letter, right? Okay, now these, let's just assume that we have done the sorting, swapping. Now what we have, now we have D here and W here, but this is not equals to this, right? So what else we need to do? We are allowed to do swap operations, right? Now O needs to be in position of L. So if I do swap of O with L, that will give me this only, right? That is our output. Since R is already sorted, so we don't need to move it. That means now we know that we need to swap second letter with second last letter. Okay, let's try this approach on this question because it is a lot bigger than the previous one, right? Now we need to do the swap of first and last. That what we have written so far. So we get D and L. Now do you see that L is also on the correct position and D is also on the correct position? Okay, great. Now second last letter we also need to move. So we swap it with O here. Do you see that now these two are sorted and these two are sorted? These two are equal. Now what is left? This part. In the previous question, R was already sorted, so we were able to get the output only. But in this case, we have more swap operations to do so that we can get something like this. So what's our next thing that we need to do? Okay, let's see if we need to do a swap of E. Yes, so E is not on its correct position, so we need to do a swap of E. We can't do it with T, we can't do it with C, we need to do it with O, because if I swap it with O, then our E will be on correct index and our O will be on correct index. So in the third iteration, we swapped O and E that was on third index, on the third index with the third last index, right? So we write here swap third letter with third last letter. Okay, now we have this thing sorted and we have this thing sorted. Only part that is left is T and C, so we need to do swap again, and only option that we'll have is T will be swapped with C, so these two need to be swapped. Okay, so let's do that. Right, so now we are able to get the output that we were supposed to get. These two are equal now. This is reverse of LeetCode, right? And the last swap that we did was swap fourth letter with the fourth last letter. After that there is no value left that we need to swap. So from this four things I am able to get that if I am on index I, then I need to swap with length minus index I. Can we say that? Because let's say the length here for the first swap, let's say here the length of this LeetCode is length of S is here 8, right? If we try to do indexing here, it would be 0 1 2 3 4 5, 6, 7. So 7 indexing, 0 to 7 would be the indexing for this array. So we swapped 0 with 7th, 0 with 7, then we swapped 1 with second last, that was 6, then we swapped second with third last, third last with third last, third is second indexed, so we swapped second with 5, that is second last, second last, oh sorry, third last. So we did, okay, let me repeat it once again. We swapped first letter with last letter, so index for first would be 0 and last would be 7. We did 0 with 7. Then we did second letter with second last. Second letter would be first indexed and last letter would be sixth indexed, right? 1, 2, second, right? Then we did third with third. So 0, 1, 2. Third letter is second indexed. We did it with fifth, that is 0. So third letter from last, 1, 2 and third. So third is fifth. Now we also did last one, that is fourth letter with fourth last letter. Fourth letter is 0, 1, 2, 3, 4. Fourth letter indexing is 3, and from last fourth letter is 1, 2, 3, 4. Fourth letter is fourth index. So we did 3 with 4. So do you recognize that we are kind of moving towards inward and we are trying to swap it based on the index? So first will go with first first letter will go with last letter, second will go with second last letter, third will go with third last letter. Can we say that I will be swapped with length minus I minus 1? So index start from 0 to 7, so last index would be length minus 1, that is 8 minus 1, that is 7 in this case. So can we say that length minus 1 is what we need to swap it with? Minus index, current index. So if current index is 0, then length is 8, 8 minus 1 gives you 7, 7 minus 1 gives you 0. So let's do that here. Length is 8, we did minus 1, and we removed the index 0 as well, so I is 0 here. So what does that give me? 7. Yes, we did swap it with 7. Then we come to the next part. 8 minus 1, we already have length minus 1. Then we did minus I now is 1, so we need to swap it with 6. Yes, we did swap it with 6. Then comes the next part. 8 minus 1, that is constant, and then we swapped it with 2, right? So second I is equals to 2, so we swapped it with 5. So yes, we did swap it with 5. 8 minus 1 6, 8 minus 1 7, 7 minus 2 5. Then comes the next part. For the index 3, 8 minus 1 minus 3, that will give you 8 minus 1 7, 7 minus 3 4. So we did actually swap it with 4. So we can say that I will be swapped with length minus 1 minus I. This statement is true for all the cases here. If you want to do it with other cases, you can do the same and you will find out that this is what we are essentially doing it, right? So what would be the base condition for this? So whenever we move into the center, we break the condition, because if we go to the next part, right, so these things will start to get reversed again. So we will start check whether we need to move t to some other place or not. That would be inefficient, so we will again reverse the whole string. So we need to do it for the center only, because as you can see here, we did 4 swaps. 4 swaps mean length is 8, so we did only half of the length of the swap. So length is 8, 8 by 2 gives you 4, so we did 4 swap at max. In this case, you can see that the length is 5 and we need to do only 2 swaps. So 5 upon 2 gives you 2, so we need to do only 2 swap. So one more thing is clear, that we need number of swap is equals to length of the array divided by 2. So number of swap would be length slash 2. That's what we concluded from here, because in this case there were length was 8 and we did 4 swaps. Here length was 5 and we did 2 swaps, that is 5 by 2. So let's do the coding for this, because now we know what we need to do and how many swaps we need to do, and we know the base condition on which we need to eliminate the loop. So here what we need to do, run a for loop as dot length. So we need to do it for the half of the length, right? So for a length of 8 we need to do it 4 times, but we need to do it 4th time too. So 8 by 2 we need to do it 4 times, right? So 0 1 2 3, right? That's 4 times. And what we need to do, we need to do a swap. So let's declare another variable. So we need to do it constant time, so we need to declare it outside. Let's just say that. So character, temporary character is equals to s dot I. S dot I is equals to the last index, that is s dot length minus 1 minus I. That's what we wrote here. That's the condition we checked. So average length minus 1 minus I, right? Now this value would be equals to temporary variable. That's how we do a swap here, and that's all we need to do. Yeah, now we can submit it. Let's see if we got that right. Yeah, so we were able to clear all the test cases, and it's a constant, it's time complexity for this would be big of n, because we need to run it for the half of the length of the string that we are string array that we are given. So it's big of n. So that's pretty much it. Thank you so much.